Hello and welcome back. It is time once again for another repair video. And on the bench today, a PlayStation 4 FAT CUH-1215A, one of my favorites to work on. And I've started taking it apart. Hadn't gotten very far. You can see what I've got some screws, just a few screws out of it. And I decided, well, maybe I should make a video out of this one. Could be interesting. And this is supposed to be no power. And if you look closely, you can see signs that there is probably some insect infestation going on. That's always nice. So I have not tried to plug this in yet. It's supposed to be no power. This is always easy to do. Not easy to do with one hand. Okay. Let's just see if it does anything. How about the eject button? Nope. If the eject does not beep, that usually means there is no 5-volt standby. Nothing. Okay. I think what we probably should do is open it up and take the supply out because I have a spare supply sitting here. So let me do that. Well, I'm just getting ready to take the supply out, and there's definitely roaches, dead roaches laying around everywhere. I just noticed it doesn't look like the right supply. Maybe I just haven't seen this kind in a while, but this looks like the kind that goes in an 1115, not a 1215. Because it has, the 1115 has these little tabs sticking up to touch metal shielding in the case, seems like. Whereas the 1215, you have a metal shield right here. You should. So let's get this supply out. And there was a screw rolling around inside this thing as well. Looks like it came out of the Blu-ray. So that one may be stripped out. That's maybe why it's rolling around. Somebody got a little overzealous and stripped out the screw. Stripped out the plastic. I mean, it's just screwing into this ABS plastic. All right. Well, these things don't like to come out sometimes. I don't want to pull that connector off. So there we are. It's the right supply. It's just, it's missing the screws or something. Or missing the proper shield that goes across there. Okay, let's try another supply. Okay, let me turn this over off to the side because roaches are going to fall everywhere. Okay, let's see. We'll be overconfident and go ahead and hook a monitor up to this thing. And some power. And yeah, there you can see some of the rust, damage, corrosion left behind. Let me just see if I can gently move this to give you a view of the monitor. All right. Will she turn on now? She does. Will she give us a picture? Okay. It's rebooting, like it's going to do a hard drive check. Because let's face it, I'm sure it powered off suddenly when a roach crawled across the wrong place in that power supply. White light. No signal yet. Well, it shut down again. The fans quit spinning. Blue light. Okay. She's just going through a check of some kind, I hope. There we go. Now we're getting some drive to the monitor. Okay. That's better. So, hopefully we just have a dead supply because of roaches. And we'll just need to do a lot of cleanup. Yeah, should be that simple. There we go. We're up and working. So let's see if we can get this original supply in there on the workbench and get it repaired, because I'd like to hang on to my spare supply. Well, here we are in at the workbench, ready to open up this power supply that is dead. I did go ahead and disassemble the entire console and to go ahead and put the pieces in the bathtub to soak. I like to try to, multitask if I can. Those need to be soaking while I'm in here working on this power supply. And that's the kind of thing you do when your girlfriend's not here. She'll never know. She doesn't watch my videos. So, let's see if we can get this thing open. And I need to also wash these case parts because they're going to be nasty inside. And again, if I haven't noticed, if there are dangerous voltages in here, so if you're not familiar with electronics, working with electricity, do not open your power supply. It's just not safe. Not a safe thing to do. Yep, I don't think this one's ever been opened before. It may never be opened again. Come on. Wow. And that's nasty. I should have done that outside. Yeah, that made quite a mess on my workbench. Ugh. So, yeah, I'm probably going to have to stop a second here and do a little cleanup. These need to go in the bathtub and soak. And I should have put down a paper towel before I did this. So let me do a little cleanup. All right, well, she's a little bit cleaner. I cleaned the workbench off and blew off the power. I took it outside and with the air compressor and blew this off a little. So it's a little bit cleaner. So let's do some basic checks here. I normally use a bench top multimeter mounted overhead here, but that's kind of hard to get in the shot, so we'll just have to get by with this old Agilent, which is something I bought broken and repaired it. I didn't do a video on it. It had some blown traces under this selector knob, so I got lucky there. So, did we blow our fuse, our mainline fuse? We did not. Yeah, right. And there's another secondary fuse here. We did not blow it. Oh, wait a minute, did we? Oh, maybe we did blow it. I guess I was reading there was some capacitance or something there. I guess I should just be in continuity mode. So, good. Open. So there's a small fuse up here. I can't recall its value, but I do have some of those. It blew. And it blew most likely because something is shorted. So what is shorted? And the most likely thing is some of these large MOSFETs. Let's just check this one, for example. No short there. What about this one right here? Yes. That is the MOSFET for the 5-volt standby supply. This IC drives the gate of this MOSFET, which in turn drives this transformer, which gets rectified and turned into 5-volt standby. So if I'm lucky, that's all that it got. But I usually, oh yeah, I may put this on the microscope so you can see a little bit better, but it normally does not get just the transistor. Depending upon how this MOSFET died, like, you know, if it's shorted drain to source, you know, you blow a resistor, you blow a fuse, and you're fine. But if it shorted to the gate, then the gate leads you back to this IC, and it will usually blow it. This thing's not made to handle those kind of voltages, and it will. So if it leaked back through the gate, and what I've been doing, I have these ICs and the MOSFETs. I'm going to replace both of them because I've done it before. I've just replaced the MOSFET. You turn it on and this chip is bad, and you immediately blow the MOSFET again because the IC is bad. So let me put this under the microscope just so you can get a better view. All right, here we are looking under the microscope. You can see this LD5760 here, which is the switcher control IC that drives this MOSFET that has shorted. Let me show you if I can get everything in the picture. Where is the MOSFET? Oh, right here. Well, it's hard to get everything in the picture. These legs right here. Let's do a quick check again. Yeah, 1.5 ohms there. Reading 63 there. I don't read a short there. No, 63 ohms. Yeah, that way. 63 ohms there. So anyway, that MOSFET's done for. The question is, what else did it get? All right, usually what it gets, if we follow, let me see if I can find it. Okay. Try to make sure I get the right trace. This may be the gate here, because I'm looking at it. See this 330 ohm resistor right here that's going through. And then it goes over here under this IC to the output pin, I think, right here. Let me make sure that's right. Consult my notes. If I can find my notes. Here we are. LD5760. Yes. Pin 5 is the output. That's the gate driver for the MOSFET. So, this is the gate. Right here. Through the 330 ohm resistor. Over to here. And that trace goes over here to pin 5 of this IC. Right here. So there's the gate. We identified that one. Now, where are the other legs? Here. I'm trying to, okay, that's what I was trying to find. I believe this is the source right here. Well, right here. Is that right? Let me get my legs right. Yeah, right here. And here is a jumper that travels over here to right here. And this is basically the return path to ground for that MOSFET. And you can see these resistors right here have purchased the ranch, as we like to say. And what these are, I believe these are both, on this one, these are two 1.8 ohm resistors, basically back to the ground or the common point of the supply inside this thing. The hot, what's called the negative of the hot side supply. It's the supply that's still tied directly to the AC line, so you don't want to touch it. But when that transistor shorts, it tends to burn these. And these are what these are current sense resistors. This is sampling the current traveling through that MOSFET, and there was a lot of current going through that MOSFET, because this is what happened when that MOSFET basically gets turned on solid and is not pulsing on and off like it should be. It gets stuck on solid, and these things are not meant to take that kind of constant heat. So, but this is how the IC over here reads the current going through that MOSFET to see if it needs to shut down or not. But their days are done. So sometimes this 1000 ohm resistor goes. Let me check it. Because if you look, that sample, like this is the low side of it. This is the common ground, or common, whatever you want to call it, the return path for this MOSFET. So here would be the voltage developed across this, and this is where that sample comes off, goes through a 1000 ohm resistor, back into the IC somewhere over here. Which one is the current sense? Pin 3. Pin 3. So that should be coming up. I'll go back to continuity. That should be coming back up to here to pin 3. And it is. So that's the current sense for this IC. That's how it reads how much current is coming through that MOSFET to know if it needs to change the way it's driving it or shut down. There's a nice solder ball laying in there. That's cute. Need to get rid of that. But let's just see. Let me go back to resistance mode. Let me check this resistor right here. Oh, 999 ohms. Well, close enough. So that resistor is fine. I want to say there's some a Zener involved in this. Where is that Zener on this one? Maybe getting my supplies mixed up. Let me flip this over. No, I think, let me get it in focus. I think I'm thinking about one of these. One of those two. Back in continuity mode. This is on the top side of the board, of course. Nothing there. Let me go to diode mode. Okay, that reads fine. And that reads fine. 0.671. So they're not shorted. I'm going backwards there. Yeah, 0.64. That one's fine. So I guess I'm thinking about the slim power supplies have a Zener that shorts. I don't see it on this one, but on some of the PS4 Slim supplies. Back in focus again. Come on. That sample across this resistor right here is clamped to a limit of, I think it's 9.1 volts. They're limiting how much of it can be fed back into here. I didn't think that's something they did on the later supplies. They did not do it on this one. They were a little simpler. Let's just check this 330 ohm. And it is fine, 331 ohms. So that would lead you to believe that we did not get excessive current back through here, you know, from through the gate. But I still just don't trust these things once this has happened. I'm probably going to replace this. Of course, the MOSFET, that, and these two resistors right here. And I think that will get this one back up and going. Let me give you a quick overview of what I'm working on here and what has failed. This is from the data sheet for the LD5760, so this is not, you know, exactly the schematic for this thing, but it's a good representation of how they use it. There's your LD5760 that you know, I'm going to replace, but here's the MOSFET that it drives. It drives a transformer, one side of a coil. Down here would be the current sampling resistors that we saw, the 1.8 ohm. They use two of resistors in parallel in this supply. And right here would be like that 1K ohm feedback going back for the current sense. So the resistors here have gone, the MOSFET shorted, and we also have a fuse back up the line up here feeding the you know, 180 volts, whatever it is. This voltage is 180 volts or so in standby mode. If you're plugged into 120 volt AC outlet, it is. But once, you know, in this design, it has a power factor correction circuit, and when that turns on, you get 400 volts fed to this. So that's why I'm saying there's some dangerous voltages in this thing you don't want to mess with. So this can be either 400 or 200 volts, 180 coming through here. So we've got a blown fuse up here, bad MOSFET, open resistors, and probably a bad IC. Well, here we are back out in the garage after a fair amount of cleaning, reassembling the power supply and cleaning the chassis. I'm at the point of testing. I don't have the Blu-ray drive in it yet, but I do have that supply in there that we just repaired. So let's just see if this will do anything now. The fan is spinning, that's a good sign. And there we go, PlayStation logo. Excellent. Well, I got a little more cleanup to do. That Blu-ray drive is pretty filthy. But at least the power supply has repaired. The case parts came out pretty clean. This thing's got some corrosion marks in it, you can see. But not much I can do about those. But there she is. She's working. I think we have a working machine here. So I think I'll end that video right here. So I hope you enjoyed that. If you found it interesting at all or entertaining, please give me a thumbs up. And I will see you in the next repair. Bye for now.